plus 1 over 2 minus 8 minus 8. Now you might say, wait a minute, this seems rather hypocritical on your part. At the start of this whole business, you said don't write equals and plug the number in, but now you're writing equals and plugging the number in. What's the difference between now and earlier in my thought process? The difference is now I know where I'm going. I understand that when I plug this number in, it's not going to give me 0 over 0. If it did, I'd have to erase it and try something else, right? The answer will never be 1 over 0 or 0 over 0. These are never correct answers, right? If you write 1 over 0 or 0 over 0, you're doing something wrong. On the other hand, if you write type 0 over 0, that's all good. Okay, so what do we got? We got ourselves a minus 7 over, I heard a 32? It's a minus 32 though, right? So lo and behold, 7 over 32, oops, 7 over 32 is the answer. All right. See if I can find another one of these to work for you guys. What if we're up against, let's do L. Well, you know, I should do something easier than L. L is kind of, well, I want to work something easier than L to kind of lead us up to the idea of L. So let me work a really simple example that I usually work in here. I don't think it's in your, I don't think it's in the homework list. Here it is. Okay, so like, example, oh, oops. That was 12. This is 13, I guess. So example 13, what if you're up against something like the limit as x goes to 1 of the square root of x minus 1 squared over x minus 1. How's that go? Yeah, that's type 0 over 0. That's right. But then the real question is, what is the square root of x minus 1 squared? Can you guys tell me? X minus 1 is only partly true. It's x minus 1 if x is greater than or equal to 1, but it's in fact 1 minus x if x is less than 1 or equal to 1. The reason for that is there's a formula. The square root of the absolute value of, let's say, a, the square root of a squared is in fact equal to the absolute value of a, which is equal to a if a is greater than or equal to 0, and minus a if a is less than or equal to 0. So in fact, what you're really looking at, truth be told, is the limit as x goes to 1 of the absolute value of x minus 1 over x minus 1. That's the same, actually. So that's a little bit tricky, and we really need to look at two different cases, right? Limit as x goes to 1 from the left, right, of this, which is what? So from the left, this is what? What are we considering there? Basically, we're looking at x is equal to like 1 minus a delta, minus like a little positive quantity. It's a little bit to the left of 1, which means you're in the case that the absolute value is eating a negative, which means it flips it. In short, to the left of the limit point here, we have 1 minus x over x minus 1. which of course works out to what? So the answer is -1 from the left. But from the right, you see we have the limit as x goes to 1 from the right. This right here, what does that mean? From the right, you can think about x as equal to 1 plus a little delta. And here, delta is a positive quantity, okay? And I usually write something like this when I'm thinking about it like this. I say delta, 0 is less than delta, and delta is much, much less than 1. So I'm thinking of delta as being a super tiny little dude, which I can think about to evaluate the limit. So, I mean, you know, see how that goes? If I've got x minus 1, well, that's, you know, 1 plus delta minus 1, which is just delta, right? In the previous one, if you think about this delta business, x minus 1 is 1 minus delta minus 1, which is minus delta, which is less than 0. So that's how I knew Anyway, long story short, x minus 1 is negative if x is a little bit less than 1. X minus 1 is positive if x is a little bit bigger than 1. That's all I'm saying. So in this context, we just get x minus 1 over x minus 1, which of course is just the limit as x goes to 1 from the right of 1, also known as 1. So my original question, what's the answer? The answer is what? Does not exist. Why? Right, because the left and the right limits disagree. This is called a finite jump discontinuity. If both the left and the right limits exist but are different, the graph is said to have a jump discontinuity at such a point. Now I just used this weird new delta thing. I haven't done that before. Let me take that out for a spin in another example, kind of show you how it works. So there's like two different ways, as I see it, of calculating limits that are, let's say, not type 0 over 0. Like suppose the limit's not going to work out. All right, so like, let's see here. Something like example 14, maybe we're up against something like the limit as x goes to 2 from the right of, oh, I don't know, something like x minus 2 divided by x squared minus x plus 2 over x squared minus 4. All right, great. So I guess I could start out by just doing algebra, right? I could start out by doing this, right? This is really x plus 2 over like x plus 2 times x minus 2. What happens then? Yeah, the x minus 2's cancel. So it was type 0 over 0 to start with. We've now got to what? Yeah, 1 over x minus 2, right? And the question is, how do you analyze such a limit? So I would say this is type 1 over 0. Now type 1 over 0 is not indeterminate. That thing just blows up. The question is, how does it blow up, right? Plus infinity, minus infinity, or does it do both at once, so we say neither? Well, this is a right limit, so it's either going to be infinity or minus infinity. Here's a way I can sometimes think about it. I think, okay, so what this means is that x is equal to 2 plus a little delta, right? So if I look at 1 over x minus 2, that's equal to 1 over 2 plus delta minus 2, which is equal to 1 over delta. Okay? What is the nature of 1 over a little positive delta? what does it do? Is it super big and positive, or is it super big and negative? It's positive, right? So this assures me that I can write that this is infinity. The other way you could do this would be to plug numbers in your calculator closer and closer to the limit point and to see how it goes, right? You could try like evaluating 1 over x minus 2 at like 2.01 or 2.001 and see what happens, right? Is it getting a really large positive number or a really large negative number? The other way you could do these kind of thing is to look at a graph. Are you confident with graphing though? Are you sure about your graphing? If you're sure about your graphing, you can solve a lot of these kind of end limits that are divergent graphically. But I personally, I call this the delta technique. It basically trades the limit problem for a algebra problem just involving either plus or minus a delta. I'll do another one of these maybe tomorrow. There's a few other things that we haven't touched on yet, like the squeeze theorem. We need to talk about the squeeze theorem. That's not a big deal. You guys will get that pretty quickly. If you guys got more questions tomorrow, though, do ask them. We do have time for your questions. I won't have much time for questions Monday because your quiz will be a little bit longer. So just a forewarning, if you're going to ask questions about the homework, probably want to do it tomorrow. Thanks, guys.